Hey everyone, welcome back to Data Skill Story Show. In today's show, as you can see, we have our guest here, Shay. But before that, for those of you who are watching for the first time, welcome. This show is all about helping you transform your data skills and make it into a bright career. So, with that, let's get started. I am Dekna. I currently work as a senior data governance analyst, and this show is all about helping you transform your data skills. And with that,
Hi, this is Raj. I'm currently working as a director of data science at a Fortune 500 company. I'm a background in robotics and artificial intelligence. Uh, that's about me. And I met Shay when I was at CMU.
I
What
can't
was
get
it,
over.
2014, 2015?
Yeah.
Yeah, Shay had just finished his master's, and then he was working for a couple of companies in Pittsburgh, went did his PhD,
Yeah.
and then he
Came back.
became a data scientist, right?
Yep.
Cool. So I'll let Shay introduce himself and give us a background about his journey into data science
Sure.
and his career path.
Yeah, hello everyone. I'm Shay Owen. I go by Shay. Currently working as a data scientist at Virtualytics. Really cool company focusing on really democratizing, AI and data exploration. So we're building an AI-driven platform at this point for data exploration. It's really cool work. So my journey in terms of data science, I started as a mechanical engineer from Iowa State, and ever since then, it's just been as a mechanical engineer, you're taught to kind of like learn a good array of skills between statistics, computer science, fundamental engineering, skills like that. And then that developed, of course, where I met Raj, where I was doing my master's at Carnegie Mellon, working more of a data science driven program where it was really on structural health monitoring within the civil engineering department there, led me into robotics. So I was starting and becoming kind of like a continuing thread through all of this is just hardcore statistics, being really strong in statistics, being really strong with computer science skills and problem solving. And all those together allows me to be really flexible in different career paths that I've taken. So when I met Raj, I was working as a perception systems engineer for a consortium between Caterpillar and Carnegie Mellon Robotics at the time, which was really cool work. And ever since doing that, I left the country to go do my PhD, where I was also doing my PhD while I was at a university called University of Queensland in Brisbane, Australia, and at the same time partnering with University of Cambridge in the UK. And a lot of that work was really AI driven reliability engineering was my thesis at the time. So it really drove me a little bit deeper into the data science world, what we call data science now, but at the time looking at it as more of, AI research and problem solving applied in terms of reliability and predictive maintenance work.
That's very cool. Yeah. So diverse set of experiences, multiple countries. So
Yeah.
do you think AI is there's a big marketing of AI and data science in US, Australia, or UK? Those are the countries you recently visited, right?
Yeah. I think honestly, it's strange because when I was in Australia, it was kind of I don't want to say the Wild Wild West, but it was really there was this resurgence of AI that was going on in Australia during my time, and I was 2014 through recently 2020,
Mhm.
and that was great. Everyone was trying it. Everyone's work had AI in it. Everyone was trying machine learning. And it was interesting because during my time at Carnegie Mellon, we were doing a lot of fundamental
Mhm.
machine learning, a lot of AI work there where it wasn't necessarily, it wasn't the sexy thing of AI that we call it today, where
so
we're,
Shay, which year was this?
oh, so when I was back
Yeah.
so yeah, this was, I mean, Carnegie Mellon time was 2012,
Oh,
2013, 2014. So at that time, we were using support vector machines, doing, object flow tracing
Right.
for computer vision.
Mm-hmm.
And at that time, it was a little bit harder. You didn't have your scikit-learns or, cookie cutter programs that you could
Like
use
there was no
then.
Keras, no TensorFlow,
Yeah,
no deep learning.
no deep learning as we have it today. Of course, I mean, I kind of people were
Then
doing
they
the
were
fundamentals
working, yeah.
of deep learning, but we didn't have it in such a strong framework now where it's adoptable by most people with certain set of skills. So it was interesting going from there and going into Australia where everyone was talking AI, everyone was trying to apply it. And it really, what I noticed about Australia, especially when I was in Brisbane, is there was a really strong following. You had a lot of people that were really focused on really getting people to know what the capabilities of AI could be and what it is, and a lot of people pushing the edges on that. And something I saw that was really nice was a lot of companies were adopting that. They were really buying into it. You had the likes of AWS, Boeing that I worked with, a lot of mining companies out there too that really just they really took onto it and really try to integrate it in a lot of their workflows and within enterprise, which is a big risk. So to see companies that are fundamental to a country's economy taking a big risk in AI at the time and not really knowing too much about it was really cool to see. And you saw the same thing too in the UK. I think in the UK, you have the likes of Oxford and Cambridge and um, uh, all the universities out there that have been trying it more on a research base. And that's something that I noticed where it was very fundamentally set in research more in the UK at the time, at least within the environments that I was in. And that's the big contrast. So that was really nice.
Right, right. So since you were in the university setup, there was a lot of research focus.
Yeah.
How are the industries doing in UK and Australia? Were there any collaborations with the university for projects, or did university, I mean, the companies themselves had like a data science team?
Yeah.
How was the scene there?
Yeah, it's that's a very good question because I saw different versions of that actually.
Mm-hmm.
So within at the University of Queensland, where I was in Brisbane, yeah, you had a lot of companies coming in that were working with different students. Myself at the time, I was working a project between Caterpillar at the time where we were looking at improving mining equipment performance and reliability.
Mm-hmm.
And when I would spend my summers or winters in Cambridge, we were working with British Telecom and trying to see how do we help them with network congestion and bandwidth utilization prediction and to be able to manage load balance within their network. And so it's quite a big range of the skills that we're doing at the time. And this was all spanning, 2015 till 2020. A lot of these type of works were happening. And also we were working with, I believe it was GE at the time that was collaborating with my particular research group in Cambridge. And so we were doing a lot of predictive maintenance, advanced prognostics with them too. So someone like Cambridge and like University of Queensland, of course they have the names, right? Same thing like we have here at Carnegie Mellon. So a lot of companies during this time when it was, the current high tide of the wave of, AI at the time, they went to these universities to really rely on the skills that were there. So you constantly saw different types of research and funding coming from a wide range of companies. And so it was really nice to be in that, ecosystem or that environment during that stage.
Right.
Because that's kind of what's happening now again with ChatGPT, right?
Right.
It's that, high wave of AI, capabilities and curiosity is happening again. So it's good.
So Shay, in 2012, would you think that data science would blow up like it is today? Like,
No. I never knew that you would call it data science.
Right? Yeah.
That's the crazy. I think that's the crazy part because for me, we were doing. I mean, you were an engineer too, Raj. Like doing electrical engineering. That was our fundamental problems that we're solving. Once you have an engineering problem, how do you programmatically solve it? How do you make sure it's automated? How do you make sure it's a robust solution that can apply? And often it's based fundamentally on statistics.
Right.
Statistics paired with, of course, fundamental engineering if you're looking at thermodynamics. But at the end of the day, it's reproducibility. It's making sure that there's software backing it that you can really apply it across as a solution. So for us, for me at least, and during that stage, it was like, this is what we've always been
research
doing.
and mathematics.
And mathematics, yeah. I always forget the mathematics part, which is ironic that I forget the mathematics part because when you think about it, the fundamentals of doing a neural network architecture, it's your fundamental algebra. So even that part, we think about all of the linear algebra and geometric algebra that we learned during school. It's like, okay, great, but unless you really go deep into it, you're not always looking at that depth of mathematics. You got the gurus of neural network architectures that really live in that space, but I wasn't there at the time. So
you're more on the application side.
Yeah, application and niche development, and really focusing on particular fields. At the time, I was really focused on prognostics and advanced prognostics and diagnostics for mechanical systems. So for me, it was like, we were creating virtual realities. We were creating sensor fed algorithms, things like that. And to me, that was just normal day to day. And now all of a sudden it has a label of data science to it. So it's
Sure.
cool.
Right.
Mhm.
Yeah. The definition of AI is also continuously changing, right?
Definitely.
30 years ago, what we call AI is no longer called AI. It becomes normal, like autopilot for flying in a plane.
That's
Things
right.
like that. They were now it's nothing. Optical character recognition was called AI.
That's
Now
right.
it's just called OCR.
It's
So
just, yeah.
the definition keeps evolving for AI. And what's your definition for data science? I know everyone I ask, I get different responses.
Definition
but,
of data science. What is the data scientist or the data science field itself? What are you thinking?
How would we define both?
Yeah, so data scientist, yeah, that's a hard one. I wouldn't want to put myself into a box by saying this.
No, that's
is what it
fine.
is.
See, everyone's looking at a smaller portion of the reality.
Yeah.
Right? So everyone has their perception, understanding of what data scientist does.
Yeah.
And what's your perception? You're not defining it
For me, it's a problem solver. I was actually just listening to a podcast the other day about what are the current challenges of data scientists, nowadays, and it really goes back to the fundamental. You have to be a problem solver and understand how to interpret your customer or your business, understand the actual problems that are needed, and often those problems are leading to decision drivers.
Right.
And that really is the fundamental core of a data scientist. Now, having the skills of, being a great software engineer, being a great, statistician, being a great, programmer, all those things come with it. Of course, those are the tools of your day to day. That's your niche. But really coming into this space and being able to make that bridge between people's everyday problems and questions, business solutions, even at that, or even regular people, day to day people's issues, and being able to connect that bridge to a automated software data driven solution.
Yeah.
That should be, I think, is what a data scientist is. How do you make standard day-to-day problems become data-driven, derive data-driven solutions to address those problems, and also make sure when they are data-driven solutions that they're driving a decision, they're making a change in how the behavior of the original problem was created.
Right.
Yeah.
I think the data science kind of the word came up when there was also a lot of data, right? There was a lot of big data, a lot of sensors, a lot of people collecting data, so it became like data science. Before that, we had to do all the data collection.
That's right.
If you're working on projects with sensors, or
I'll tell you a funny story. It's funny, when we talk about data scientists, and I look at what we do today, and a lot of us, we all work from home nowadays, but you get your data, someone else has they've gone collecting the data, it's sitting somewhere, and then you're taking it, and it drives your solution. I remember, I was like, we were all there when we were all undergraduate researchers. When I know at Iowa State, for instance, I was very well connected with the civil engineering program there, and we're doing structural health monitoring projects, and we had to go. I remember like 5 a.m. or 4 a.m. in the morning. We had to go to a bridge camber or bridge structure where they were building all the build structures or the bridge structures out there, and we had to go measure all the cambers and be able to detect. Looking back on it, we're trying to figure out the production process and how that affects the quality of the said beam that they were looking at. So sometimes it's the beam, sometimes it was the rebar, whatever that they used to construct, but mostly we were looking at the beams and being able to detect, because certain beams need to have a particular camber when they're going to be ready for installation. So we're like to connect production and process, quality, and the final result and usability of the particular beam. That's data science today. When you think about it, it's like, well, these guys have a problem. They want to be able to make sure their quality is reproducible, is at a particular standard based on the process. They want to be able to detect when that process changes, how it affects the outcome.
Right.
Being able to derive a data-driven solution to that is what we were doing back then. We were using pot sensors or dash pot sensors, I guess, and we're collecting, the measurements off of the cambers given a particular production time and a crew. Nowadays, that's what we do in data science too. Yeah, it's a little bit more abstracted from the physical sense. A lot of us tend to just deal with the data, but having that understanding of the fundamentals of the source of the data and the process is going to start to be very, very important as we want to make stronger solutions and more, I would say, reliable solutions that people would want to use.
Yeah. When you said when you said part sensors, are those the resistive
Mm-hmm.
potentiometers?
Yeah, the dash pots. Yeah,
Got it.
yeah. So yeah, it's pretty much it's a dampened sensor where you're trying to measure what the actual camber of the beam is at the time. Yeah, it was pretty interesting. I look back on it, I hated those mornings, but I was part of a data science pipeline at the time.
Mhm.
Yeah, because I mean we
So,
took that data and we analyzed it in the lab after that.
Right.
We were using Excel spreadsheets at the time and
Mhm.
simple Python code, but yeah.
Mhm.
so what were those roles called for? Like,
That was a researcher. that was a undergraduate researcher, and that was it. You were a research engineer, and that's it's funny you asked what those roles were called, and I look back on it where from my undergraduate days as lab researcher, undergraduate researcher to internships working with Caterpillar, for instance, in the prognostics, it was advanced engineering researcher, or even my most recent role prior to joining Virtualytics, I was an AI researcher.
Mhm.
And a lot of it has always been put into R&D. And we can talk about that later in the story, but that's where a shift for me now too, in my data science role, where it's more on the production side, it's more customer facing. We're really developing code and developing solutions to hand to the customer and have that immediate interaction. Whereas as a researcher, because there's been, I think, in the past, when we look at it, not necessarily a hesitance to deliver the product right away, but it lives in that research world a lot longer.
Mhm.
And that's something I'm seeing a shift in these days where, like you're saying with the title and the role, it's no longer just a research. No, let's take this and drive it and put it right in front of the customer and then use that as feedback and keep developing a solution from it. That's something I don't think we often saw in the past. It really, I know at Caterpillar, when we're doing R&D, things will cycle for months, and you just keep iterating, you keep collecting data, you keep writing program. We lived in MATLAB a lot during those days, and yeah, your job was to be a research engineer, and that was that.
that's
Yeah.
nice. Yeah. Yeah. So for those of you watching, put your questions in the chat. The last 10 minutes of the session, we will be taking all your questions. And also let us know where you're joining us from, so we can see who all joining from different parts of the world.
That'll be cool.
Yeah.
So, moving to the question, right? So this topic is about future of data science,
Yeah.
AI. We talked a little bit about where the AI came from, or what the machine learning is all about.
Yeah.
10 years ago, right? When you were in CMU, you talked about using support vector machines, statistical models, etc. And then we talked a little bit about deep learning. Now that was the evolution beyond that. It became really popular at the advent of GPUs and stuff. We're right now there with like a lot of deep learning. We saw ChatGPT come out recently. Right? So where do you see this trend going?
I
Where do you
think
see we
before that, I want to ask Shay a
Sure.
question.
Yeah.
Like, what do you think about ChatGPT first?
What do I think about ChatGPT? I honestly, I went online and I signed up and I used it and I was like, okay, great. And it wasn't like, oh, this isn't impressive. It's generative AI. Like that's the accumulation of, I don't even know, like 10 years of work that somehow someone was able to curate that amount of data and be able to train a model to be able to get the level of accuracy that it has now. But I mean, all in all, we all know at the end of the day, this is still, one word, feed forward prediction using your series of, complicated NLP networks. But it gets to a point where I think we're now how do you put it? We're now not necessarily the guinea pigs, but we're now the data feeding back to ChatGPT for it to therefore be iterated. I think it's now like version 3, I think is what we're seeing right now, ChatGPT 3, where maybe 4 is going to come out of all of the users. I mean, I think they said like 100 million users or something like that in a month or something. And so like, that's a whole new source of data that I didn't have before, because I think what it's lacking right now is context. Right now, when you have a conversation, you say, well, who is the president of the United States and who was the president of the United States? I don't necessarily think the algorithm knows what a president is, but it knows that from the lexicon and series of text that it's learned, it can pick and source from different parts on the internet and different conversations or different texts that the president of the United States is Joe Biden, so forth and so on. But knowing what a president is and what a president should be doing, I think when you can start having that conversation where who is the president of the United States and do you think he's doing a good job? Would like to have a conversation. Well, based on what I know about our president, this is not, this guy's doing great or he's not. I'm not really too much on the political side of things, but what if based on information gathered from different sources and derived contextual data that you can have that conversation with an AI algorithm? And I think that's really where the next frontier of something like Chat GPT will really go. That what could be maybe 3.5, version 4, that is really where people can start to really get the best out of a tool like that.
Right.
Yeah.
And there's a lot of things that ChatGPT today makes up, right?
Yeah.
There were cases where the data doesn't exist.
Yeah.
The numbers and the dates don't exist. They just made up.
Yeah.
That's the problem with ChatGPT 3, and heard some podcasts and other sources
Sure.
that ChatGPT 4 is going to fix that with citing the sources. So it's
Sure.
going to give you the source from where it got that information, which is going to be useful for your research to understand how it's doing. To a certain extent, Google does that in the search today. When you ask a generic question, it shows you from where it picked up.
Yeah, it's a little like grayed out section on top. Yeah, I see that. I think it's going to be good because if you ask ChatGPT right now and say like, how do you take apart an engine? I'm sure the way that it tells you to take apart an engine isn't necessarily the most optimized way to take apart an engine, because if you gave that explanation to someone that is a mechanic day in and day out, and that's a leading statement that I make there, because when you think about an engine, we all know there are variations of engines,
right.
And the difference between your BMW engine, the innovation that they put in to make their engine work, that's not the same way you would take apart a Mercedes engine,
right?
Something like that, where it necessarily isn't at that stage right now where it's like, yeah, you want to take apart an engine, but having a conversation and being able to say, okay, well, given that this is the engine that you want to take apart, this is where you should go. Because reality right now is, if I ask you like, hey, how do I take apart an engine? The first thing you'll ask is like, what engine?
Exactly.
Like the engine for a motorcycle or engine for a car, or So it would be, while ChatGPT might be able to do that and ask you to get more specific, knowing the intricacies of how to give you the best solution, or actually a correct solution,
right,
and not confidently giving you a wrong solution would be the next, I think, evolution of that. So it's great. I think we need to use it. It's at a stage where we need to interact with it because we want to make it better. Right. So let's give it more data. Let's make it more understanding of the context and understand how to change not change conversations about AI in terms of making it more reliable. I think that's a big part, right? And we saw the whole situation with Microsoft where they pulled the plug on it, because it derailed very quickly.
This was the Twitter bug from Microsoft, right? Yeah. Cool. Yeah. So what next after ChatGPT? What do you think? Where do you think the world is going with data science and AI?
I was thinking about this the other day too, and why? Because at work we deal with this quite a bit, and what I'm noticing, and every time we see this resurgence of interest in AI, it really forces. It's kind of like you need a big leap forward to kind of bring the fundamentals up with it too, or catch a lot more people up. And I won't go into the depths of saying, well, next it's going to be conversational AI where it's truly intelligent and understands context. But I think bringing it to a more grounded conversation where now we see what is possible. Now let's really understand and create more confidence on what we're already doing really well. If you guys do this too day to day, a lot of the work that we do actually in industry is still fundamentally based on machine learning. But we're still facing the challenge of getting people to trust just that machine learning solution when there are business dollars associated to it. So I think when you get this where you kind of increase your boundary, increase the field of capabilities of AI, it also better centers the capabilities of the current fundamentals, like machine learning, even your fundamental statistics that we're calling machine learning, or logistic regression, for instance. Let's go there. It builds more confidence in those works, and it, for us as a data scientist in day-to-day roles in enterprise, it allows that conversation to be a little bit more straightforward. And being more open, I think, is something that, I don't know, for me in my field, like you have to be honest with your customer and say, look, this is the capabilities of the model. This is what it can or can't do. But now I think the further we push the edge on deep learning, those conversations can be not met with criticism, but more met with understanding. Like, hey, these are fundamentals that still work. We know what the bleeding edge is, and it creates that good contrast between what's really bleeding edge and what's really actually working day to day, and people will kind of hopefully buy more into it.
Right.
So that's my different spin on where things go. I want the guys that are really deep into it, that know what they're doing. The guys like OpenAI, let them keep pushing it because it helps the likes of us that are applying and developing still novel work, novel solutions, but using the core methods that we know it's explainable still.
Right.
Because that's going to be important. We have to be able
Explainability is
to
going to
explain.
be, it's going to gain traction, you think?
Yeah,
We'll see a lot more explainability for the deep learning models also.
I believe so. I know we've seen a lot of work where I think it was probably like 5 years ago. No, it can't be. Maybe like 2019, 2020. I saw there was a big work at MIT on explainable AI, explainable neural network architectures, and being able to associate different neuron weights with certain different decisions. And I still see that they're making good traction on that. But at the end of the day, when there's dollars associated to the model's performance, someone's going to ask you, what's the fundamental map to it?
Right.
And I think the more we can do that now with what we know actually works, we can build that trust in the industry. Because, I mean, you look at, finance sector, banking sector, you look at reliability in terms of, automatable performance, or even when machines that are automated are working with or operating with humans, we have to be able to trace that back to saying, this model or this machine behaved this way because of set actions within the model, or these particular arithmetics where we're driving the decision process for a particular model.
But when you have billions of neurons, right, and the weights and biases for it,
It becomes intractable at some point.
yeah,
Agreed.
It's very difficult to trace. So correct me if I'm wrong. Like, I've used this to explain business folks at some point. They ask me, how can I trust this AI model?
Yeah.
When we use deep learning model, it's very easy when we have statistical models. You're talking about logistical regression, or any kind of regression, or anything based on statistical models.
Yeah.
But when we jump into neural nets, and the neural nets becomes large enough, even 1,000 neurons plus, gets really difficult to start explaining as to why it's making that decision.
Yeah.
Right. So I used to explain it this way: we build this model, we think it's working this way, but we don't know. So what we're going to do is, why don't you test it in the situation where you would use it, and have a human shadow every single decision that it's making, and see if it makes sense. If it doesn't make sense, then give us a sample where it didn't make sense, and then we're going to get into that space, test a little more, and retrain the model so it's not biased, or it's not, because we don't know everything until we test enough samples.
Of course.
It's just like, if I ask you, you ride a bike. How do you ride a bike? Can you explain it to me? It's
Sometimes, you can't. Until today,
you can't explain, but you can ride a bike.
The crazy analogy that I bring that back to, I take it back to engineering again. Have you ever tried to tune a control algorithm or a control process? It's one of those things where you have your fundamental PID, but very quickly it goes away from your fundamentals PID, proportional, integral, and derivative controllers, where for those that aren't engineering, that's essentially a way of how your suspension system in your car works. When you're driving your car and you go over a bump and it quickly settles back down, and it's almost like you didn't feel the bump, that is a PID controller. Often these days it's probably more algorithmic based. Probably machine learning is working in that these days.
I mean, PID is used in air conditioning. It's
so your simple air conditioning system, 100%.
control,
So it's one of those things where you can't always explain the ways of, you just know that you set it to this parameter, it's bounded to not behave, to this lower threshold or above this particular threshold. And that's the confidence you give. So something like that, when you think about engineering, when we talk about, what's been going on, 15, 30, 40, 100 years ago, PIDs are one of those things where I remember when you go into, I forget the technical term these days, but you go into a situation where your controller bounds your system is behaving completely out of the controller bounds, and you might not know why, but you don't know what disturbance that it's been excited by that you didn't calculate for. Because in lab, in design, even in fundamental equations, you might not be able to control every factor that particular user or that system might interact with in a real world application.
Yeah, the systems are complicated in real life. In simulations, it's simple because you define the system.
Exactly.
real life, there are so many factors that you can't account for.
And I think that's the same perspective that we have to take with AI. And that goes back to my earlier point of the more we can, ground the capabilities of the fundamentals of machine learning to a point where there's a strong trust and belief in how those models work and how they've been created, sooner we can hopefully start garnering the trust of, these advanced neural network models where even for us, it becomes intractable to be able to tell you like, hey, it's actually this particular neuron or this base model, because you got a lot of ensembles of models that are working now. We want to be able to get to a point where it's like, hey, we might not know, but we know within the bounds of what it should operate in. And when it doesn't, okay, fine, we can have that conversation of, why did that model lose confidence in its particular performance?
Mhm.
But I do think when we can have that same conversation of, yeah, when you tune a particular suspension system with a PID controller, people still go out there and drive the car. Your likes of people at Mercedes or Daimler or BMW, they're still they still go on a test track. They
Right.
tune the suspension, they tune the controller, and then they go and they test it,
Right.
and they see how it works, and they collect more data, and they go back and iterate. And that's the same approach we have to take with when you deploy an AI model. Yeah, of course, get your best accuracy, get your best performance, but knowing that eventually that's not going to be the final stage of the model. That second phase is interacting with the human and getting more data, like what we're doing right now with ChatGPT. That's exactly it.
Yeah.
So yeah,
So, Shay, what do you think some of the challenges are when it comes to the data science role specifically? Like you were talking about the evolution stuff, right?
yeah,
So, what do you think the challenges would be? Like, what in future, maybe like 5, 10 years, what does a data scientist? What kind of skills does a data scientist need
yeah,
to get into this career?
yeah. I think you as a something. What's funny? It's not a dilemma, but it's a thing where too I'm at a stage where I'm making sure that my skills are staying in a particular, set or range of capabilities. What I mean by that is being a data scientist that you can just sit in a room and someone tells you to tune this model and you just produce a model. Those days are long gone. I think that lasted for maybe like a year or two. But now as a data scientist, you need your statistics are definitely going to be fundamental. Your mathematics capabilities are going to be fundamental, but also your problem solving. Being able to disseminate, it goes back to when we're all taking SATs, your word problems. How do you actually identify what the solution is and what the actual problem is being conveyed? We're going to have to be able to do that. You're going to actually have to engage with the customer and understand what it is exactly that they're asking of you, and then craft a solution from that. And it's going to go back to that metric we always say, where maybe modeling is only going to be what is now 10%. Maybe that's only going to be like 2%, because we do have such advanced models.
Right.
We do have, already,
Self-tuning,
all those approaches are there. What the real challenge is, how do you craft and shape the problem that the customer is asking for, and understand the problem, and translating that to a data-driven solution again. Modeling, all that stuff, I think we're all going to get to see that becomes very easy. Being able to understand and interpret the data actually is going to start becoming the real challenge, which it already is. And I think the cool part is, as we're getting more people from different backgrounds that are coming into data science, we'll hopefully be able to create a template or a process beyond just your standard feature engineering or implementation or working. I think the solution I always hear a lot is working with solution matter experts or subject matter experts.
Right.
Even that's going to become point with how do we still do that, but still rely on fundamental mathematics. So for me, if to answer the question even more simply, I think it really is going to start evolving to becoming a really strong problem solver. And realizing that the modeling and the statistics are all part of tools that you should have and keep growing, but understanding how do you solve a problem and how do you actually make data-driven solutions from that set problem. Because like we were talking about earlier, data science has quote unquote been around for a while. Now that you're using AI solutions more predominantly, it doesn't necessarily change the research or the mathematics that we've been doing since day one.
Yeah, this show is about skill stories, right? So we like to talk about the skills and story behind, how do you acquire a skill like that, or what is your suggestion for others? So you're talking about these important skills, which are like problem solving, analysis, let's say, trying to understand what the model built. How do you understand the problem and then right solution using the right tools to solve the problem?
Yeah.
how do you develop these skills, and what are these skills called exactly?
Yeah, it's weird because I remember in undergrad we used to make fun of like political science kids. We'd be like, oh, we're in engineering. It's not that hard, or even like psychology or sociology majors and stuff. But the irony is that's the skill that you need now in data science
Right.
to actually be able to sit down with someone in a room and they're going to say, hey, you know, I want to know, how my cat's feeling today. You can be like, okay, well, yeah, you can make a system that monitors the cat, but the real question is why?
Mhm.
Why do you want to know how your cat's feeling today? What's the actual course? And being able to communicate with the customer or with your own internal customers at your company to understand, okay, what is the actual end goal of the solution that you're asking for? What is the actual problem that you really have? And being able to help people interpret their issues.
Right.
Because everyone wants the cool factor of having a data-driven solution. Everyone knows already, the amount of money it can save, the returns on revenue, whatever it may be. Everyone already understands that. But being able to get to that,
Right.
that's the big leap. And I think that's what, I'm very lucky to work with really talented people at Virtualytics, and that's something that I see as a consistent skill
Mhm.
in every strong performer. And I would say everyone at my company is a strong performer, but that's a core skill that I think they all have,
Mhm.
where being able to communicate with people and being able to, it doesn't mean you have to be this extroverted individual, but
Right.
being able to listen,
Mhm.
being able to really be invested in the problem and in what the customer is looking for. That I think is, so when you say, how do we put a label, broad stroke over it, it's going to be the soft skills.
Mm.
How do you interact with people? How do you understand the problem? And how do you then it really, you can take it into your ballpark of the mathematics and problem solving, being able to disseminate what the problem is
Mhm.
into a solution. Because we all know we're going to spend days, hours on feature engineering. We're going to spend days, hours on the modeling and iterative process. But really, a lot of those days and hours become more fruitful when you know that you're solving the actual problem that the customer wants,
Right.
not just to create a model or a solution. Great, we just paid you a couple $1 million for this, but we're gonna go shelf it now because
Right.
we didn't know what our problem was and you didn't know what our problem was either. So we're all just gonna not blame each other, but we're just gonna walk away from the solution. And
Yeah.
you don't want that, because we go back to, again, building the trust, building the reliability in AI. We want to push the field forward.
Mm.
We have to start understanding the people that come to us, because someone might say, hey, I need to use logistic regression to answer this problem, and you're like, that's not even that's not even a classification problem. Like, how do and so it's one of those things where instead of like pushing them away,
Right.
let's actually understand, like, why do they think they need a logistic regression?
True.
Let's see what actually the problem is that they're trying to solve.
Right. I have a very good example of this in my early career in data science. I started working with a junior AI researcher, and um, that person was solving this problem where there was too much noise in the document,
Okay.
and they were trying to denoise the image so you can run OCR on it
Okay.
and get better results in the OCR.
Yeah.
And the person didn't ask the fundamental questions at that point. And when I was brought in to lead the project, I looked at it and I said, "Who are scanning these documents? Why do we have such bad quality? Where is this? What's the source?" And then I realized it was scanned internally in the company. the The original documents are pristine, really good,
Yeah.
because these are important documents, and then it was scanned, and all of a sudden the scan becomes really bad because the scanner settings was not set right.
Yeah.
So I went in and
Or
went
like
in the scanning
20
room.
DPI or something like that.
The resolution was fine, but it was so in order to save the size of the image or the PDF, right? They set the settings to convert everything to black and white instead of grayscale. Right. So when they convert it to black and white, something is gonna become
All the
bad.
noise, all
Yeah.
speckles on the document start showing up too. Yeah.
So it went from a computer vision problem to denoise the image, binary image, to just fixing the settings on the scanner, and you don't have to deal with this problem ever again.
Yeah.
Right?
Yeah. No, I agree. You see that every day in industry. I know I was doing a project with a company called Fortescue Metals Group in Australia, and that was something that I really picked up from there, where I saw that we invested probably a month or two, in the beginning of a project, just to really talk with the customer and just really understand their setting
Mhm.
code. Or no, it's like, let's go live with the chemical engineers that want to do
Mhm.
fuel analysis and understand when you need to change the oil based on fuel analysis of a particular engine. Let's go see what they actually do. Let's see how they work day to day. Let's see what are their real challenges, what are their real problems, because that goes back to what we're saying. How do we actually solve the problem?
Right.
How do we actually be able to now architect a solution for them that's going to be useful?
Mhm.
Yeah. Yeah, with that, so let's like start winding down. So what are the two skills that got you this job?
My
I think you already mentioned
my
but
current job,
just two
man,
skills. Yeah.
I I guess. I mean, I try to think about the interview process. Where I think for me, to be more candid, so this particular role, it really was brought. I was brought in to kind of do what my thesis was on. It was really starting to work on machine learning driven predictive maintenance problems,
Mhm.
and that's a lot of the core of my work day to day. And so that really was what brought me, or even attracted me with the company, was they have a lot of predictive maintenance solutions or problems that they need solutions for. So the skills that go with that, fundamental statistics. It's the irony of it is maybe that's why I harp on statistics so much. But reliability theory and reliability engineering
Mhm.
is 100%
Mhm.
in just core, pure, like fundamental statistics, because you're looking at predicting, time to failure.
Mhm.
A lot of those things are grounded in distribution analysis.
Right.
A lot of it is grounded in your basic understandings of how different distributions work and when they're applicable to different scenarios, and being able to describe
Mhm.
your world based on the data that you're seeing from your world. And I think having that skill be my bread and butter allows me to be able to translate and work in these different environments.
Mhm.
So I think understand statistics and how to describe the problem and solution through interpretation of the data. I think is something that is really core.
For someone who might not be in mechanical engineering or any kind of engineering,
Yeah.
how do you describe what you do when it comes to predictive maintenance? How does this problems that you're solving change the world?
Oh, it's I don't want to simplify it to just simple forecasting, because it's not.
Mhm.
Predictive maintenance is really understanding the logistics and ecosystems between the people that are keeping a particular system operating, how they interact with that particular system. How does that system give them feedback to do their jobs
Mhm.
the way that they need to? Is it early detection or early warning of, hey, I'm going to fail in X amount of hours or X amount of days? How does that change? It goes back
So
to
this goes into something like manufacturing industry.
yeah, manufacturing, automotives, aerospace, mining. It's in every industry that you can think of, even in the medical to a certain extent, and prognostics. It's really understanding, how do we impact the environment that is used, or the system that's used to maintain a particular equipment or to keep an operation alive. If that operation is able to give you feedback on, this is when I think I'm going to fail, or this is when you repaired me last time, it wasn't the best repaired, so therefore I'm only going to last this long to complete a mission.
Right.
It impacts the whole ecosystem logistics around a business,
Mhm.
because if you think about it, a lot of things are asset driven.
Mhm.
Your trains, your automobiles, your airplanes, like even your spacecrafts.
Mhm.
Being able to understand the safety aspect of that, to know that, hey, this is the condition of what I'm working with right now, becomes very impactful.
So, like in the case of vehicles, right? So we have these days cars show you can drive 3,000 miles before you need a service.
Yeah.
So are those fixed, or is there any predictive maintenance happening there?
I think it's starting to come to a point where industries are starting to trust the capabilities of algorithms, where you are able to use what is considered fixed or cyclic timestamp. So I know if I turn this wheel 1,000 times, it's going to start to degrade. So there's a little combination of that versus also looking at the condition monitoring of the system too, and saying, well, yeah, my oil level is down. I have heated up to this temperature a couple times. So therefore, I think I'm only going to last this long in the mission. Starting to see fundamentals of what it was, manufacturer based time to failure, you can call it that, and also what's actually conditioned in the current state, and being able to use sensors for that. So it's going to transition to be both.
Yeah, this can be very helpful for environment also. Save you money, save you don't have to change the oil so frequently. Maybe change something before it breaks. That we're not stranded in a desert driving or something.
Or even more importantly, not changing things before they break, right? Because
Yeah.
if you manufacture high tolerance equipment and you're changing it every 10 days versus every maybe 40, 50 days, you can save some money on that.
Got it.
Mhm.
Got it. What do we have
Yeah,
next?
so let's wrap up and
Questions.
just one more question I have for you. Other
Yes.
than data, being a data scientist,
Yeah.
what is the other thing that you do?
Oh, what do I actually do with my life? No, no. I like to travel a lot, and what comes with that, that came out of that is photography.
Mhm.
I love to take different type of pictures, and I spend time less now than before, but I used to spend time just editing images.
Mhm.
Just take pictures and see whatever I could do with it. I don't even remember, but we had a sensors system and sensors class
Mhm.
at Carnegie Mellon. I forget who was taught by it now, but that was where
Was it Mel?
yeah,
Siegel?
Bell Siegel,
He's
yeah.
my director, yeah.
Yeah, okay, yeah,
Great
Siegel,
guy, yeah.
amazing professor, but he was really into photography too, and that was one of the times where I was like, oh, I could actually start to play with what I do day to day and the images and photography that I take. So those are my big things I like to do when I'm not coding.
Awesome.
Yeah.
So yeah, we have a couple of questions here. So let's take the first question. So I think Rutuja is asking, is there no jobs for freshers in data science?
Freshers. I know exactly that term. I know what that term is. I think there is. I tend to see it lean more towards the data analytics
Mhm.
because I think when you do a lot of analytics and you actually just try to analyze, you're in that middle of where here's the data, what questions can we answer using this data? I think that becomes a very, very strong skill.
Mhm.
So fun, just sit in that space and understand, yeah, you're not going to understand where the data is. You're going to get a clean data. You're going to eventually learn how to get the data to that point where it's clean. We all work through that day to day because data changes, but being able to answer questions from data and create your Power BI, dashboards and things like that,
Mhm.
those are just as important skills. And that's something you can pick up right out of college or, even in high school. We have a lot of high school interns that come in and do that type of work.
Right.
So,
Awesome. And one more question. So Sagar is asking that he started his career 2 years post graduation and later started working in a BPO for the past 2.5 years. How can I become a data analyst without fake experience?
without fake experience. What is fake experience? I think I get what I might be saying. I think in the sense of maybe like using real data or actually having interaction with the customer. I did this when I was doing a PhD where I just went out and I wanted to write more papers, so I needed more real data to answer the question even more pointedly. I needed to actually have equipment data. I needed to actually have an industry problem. And so I did just go to industries and I offered my work as like a research solution and gave them a paper out of it. And so look, I'll write the paper and I'll put the lead engineer on as a second author, things like that. And I think those are great ways where you can put yourself in a real environment where no one's really taking a risk, right? Because while they might not be developing the solution already and they might not depend on what you need to do, you can still do that work on the side. And eventually, when you do get things right and you do have a fundamental solution that's applicable, you can present that. And they can therefore make a decision. But it's nothing lost, nothing gained in that interim process. So I think being forward and trying to get in front of different companies that might have good data already and they have a problem, but they don't have the time to solve it, I think that's a great way to start.
Awesome. Yeah, and I think we're like super over time.
Oh, definitely, sure. I'm a long-winded talker.
The time just flew.
Yes.
This was an amazing conversation, Shay.
Yeah. So yeah, I think we're gonna wrap up now. So thank you all for watching. I hope you really enjoyed the show. And thank you, Shay, for being here
Thank you guys for having me.
and sharing
Appreciate
your
it.
knowledge.
Yeah,
Thank you so much. Thank you guys. Thanks, everyone.